What's going on, everybody? My name is Johnny Bandon, and I will be your CCNA instructor for this CCNA video series. In this video, we're going to continue with our ARP section, and we're going to go over ARP in real time, right? So what we're going to do here is we're going to assign PC3 a static IP address, and then we're going to try to attempt to do a ping from R2 to this PC. We're going to see the first ping attempt fail because we're doing an ARP request. And then we're going to inspect that ARP packet here. And then we're going to look at our ARP table after the fact and see that layer 3 to layer 2 mapping. And then on PC4, we're going to set it for DHCP. And we're going to see how ARP is used in DHCP to discover our default gateway. You're going to see essentially it just goes and asks who has this, right? And then if someone has that IP address, i.e. the DHCP server should in that subnet, right? Then we're going to get an ARP reply, or really that ARP request is going to go through. And then we're going to be able to have DHCP communication. And we're going to see that on the wire as well. Awesome. So again, for our paid viewers, this lab should already be pre-configured for you, because this lab, like all of our labs, are available for you to download at our central repository. For our free users, feel free to go check out our EvenG videos to learn how to build a lab just like this. And then, of course, this Git lab we give to all of our CCNA students has baselines and instructions and solutions in this repo. So let's go ahead and get started. So first thing I'm going to do is go ahead and stop these nodes because I was just doing some configuration, and we're going to reboot everything, bring it back to baseline. And what's already configured is DHCP and our sub interfaces. So we'll go check that as well before we start. And then this trunk should be configured here. And then the access VLAN should be created and assigned to their proper interfaces here. So we're going to go ahead and check that before we begin though. So now these devices have booted up. Let's go ahead and secure CRT into them. We're going to do that by just clicking on this device, hitting Open Secure CRT, which is the native console that I use and everyone should be using, right? These PCs didn't start. Let's go ahead and start them. Okay. And then let's go into our secure CRT. So the first thing we're going to do is, again, just check these network devices and make sure that they are properly configured. So we're going to log in with our username and password here. And then the first thing we're going to check is to make sure these sub interfaces are created. And let me zoom in a little bit. Why aren't these PCs starting? Okay, there we go. Sometimes EvenG, right? It's not always 100% perfect. So these sub interfaces, they are configured correctly. Now let's just check our DHCP configuration. So it's going to be show run pipe section DHCP. And just a little slow here, that's okay. I'm probably just throttling my CPU on my laptop I'm using. And we have a DHCP pools created as well, which we're only going to need for VLAN 10, but we just created both of them. So now let's go ahead and get into our PCs. And before we get into ARP, let me again just do some verification on the switch. So we're going to check to make sure our trunk is created. And then we're going to check to make sure that our VLANs are assigned and created properly. So yes, we should have a trunk on 02. Then we're going to type in show VLAN brief. VLAN 10 and 20 are assigned correctly. And now let's go ahead and do start our packet capture on ETH00. And then from PC3, we're going to set a static IP address. So it's going to be 192.168.20.2/24. And then we're going to set the default gateway. Okay, so we have set the IP configuration for this PC, right? So we should know where to send traffic. Wrong. Because we know the IP information does not mean we can build and encapsulate the IP packet with the correct destination MAC address in our Ethernet frame. Because this PC isn't a switch. It doesn't know about all the MAC addresses in the LAN or in our campus or in our environment. So we're going to have to figure that out. And we're going to figure that out with an ARP request. So I have my packet capture going on that interface. And let's just try to ping from the router. So the router also doesn't know how to fully build a packet to reach that PC. Because if you look at its ARP table here, it just knows about itself. But when it tries to ping this PC, it's going to be like, well, I don't know how to reach it via layer 2, so I can't do the encapsulation to reach that destination IP. So you're going to see one ping fail, and then we're going to see the rest hopefully be successful. We're also going to source this ping from a different network, from our VLAN 10 network here. Let's go ahead and check it out. Awesome. So I'm going to stop our capture here, and you can see one of those pings failed, and the rest were successful. And that first failure is because of ARP. So if we hit up arrow and ping again, we shouldn't have that issue, because now we know the MAC address of that destination IP, meaning we can build the entire data packet with that Ethernet frame and header with the correct destination MAC address. So let's bring up Wireshark, and let's go ahead and look at that ARP request. So we did our ping, and the first thing we did was ARP, saying, and you can see it here, who has 192.168? Tell me I'm the source. So you can see here, under the Ethernet section, here's the source MAC address, here's the destination. So that ARP request went out every active port on the switch, meaning that this PC4 also received that ARP request. Okay? And now let's break down the actual ARP request. You can see it's saying protocol type is IP. We have our source, our sender MAC, our sender IP. Then the target MAC address is just left blank, meaning, hey, 192.168.20.2, we don't have a correct target MAC address, which is why we're asking for it, right, in this ARP request. Okay? That's why it's left blank. It's a null value, right? It's all zeros, because we need to fill this with the correct information. And you can see the Ethernet header is built with the broadcast MAC address. And then we have that ARP reply. And look, now we can fill in the target MAC address, because the sender IP, which was our destination here, right? See the difference? Received that ARP request and is now replying saying, hey, this is my MAC address here. Okay? And then after that, now you see full reachability, where that Ethernet frame is encapsulated correctly with the correct destination MAC address. Awesome. So that we can really end the video here now that we've seen ARP, right? We've seen it in action. This PC should also have an ARP table built. Show ARP. So it says empty, but if we just send another ping back, and now we see it's ARP table. And remember, these virtual PCs, I think they're like open. What's their OS? It says it up here. It's BSD, so another open source. So it's not like anything you're going to be used to in any environment except when you're training on EVE-NG. But that's the ARP table for the PC. Now let's go to PC4, and let's go ahead and do a Wireshark capture on ETH01. Let's do a capture on ETH00. And why are we doing this? Because I want to show you how that ARP request does go out all active ports, right? So we have one Wireshark capture here from ETH01 and one on ETH00, because I want to show you how the ARP goes out all active ports. So now we're going to go back to PC4, and we're going to send a DHCP request. And in that DHCP request, the first packet that gets sent out is an ARP request. So let's see, right here we have our DHCP discover, which nothing is replied to, right? And then we have this ARP request. So let's kind of see what's in here. So in that Ethernet header, we see the broadcast MAC address again. And then we have an ARP request here. So we see the sender address. It's .1. Well, why is that? Well, because this PC doesn't have an IP address yet. So it's trying to just send out to anything it believes could be on the network. But this is an ARP request. So at layer 2, we're going to get a response, right? And then once the default gateway, which is also has DHCP configured, so once a DHCP server, I guess would be more accurate to say, receives this ARP request, which the entire network should, right? It's going to send back an offer from that next DHCP discover, because now it knows that there's a device out there looking for a DHCP server. And then I said earlier that I want to show you how ARP went out to the entire network. But as you can see here, that ARP request didn't come. And that's because, again, we're using VLAN. So I misspoke. VLAN 10's traffic isn't going to reach VLAN 20 via layer 2, right? So kind of cool, just another cool way to see how VLANs truly segment your network as well. Okay, and that's going to be it for our ARP lab. I hope this helped kind of bridge that knowledge gap if you didn't know what ARP was or what the purpose was. Before we leave, actually, let me just go back into R2 and show you with ARP table. So IP ARP. And now we see that it has all the devices in our network here, right, mapped. So pretty cool. It actually shows the age too. But awesome. So I hope this video was informative, guys, and I hope this has helped you learn ARP. And stay tuned for our next video where we're going to go over inter-VLAN